Welcome everybody. We are given this question: x positive y is equal to 3 and xy is equal to 3 squared. Now let me start the solution by rewriting it as this is going to be my first equation: x positive y is equal to 3 and xy is equal to 9 is going to be my 2. Now from 1 we have y is equal to 3 negative x. From 2 we have y is equal to 9 over x. Now this is a rectangular hyperbola that has asymptotes along x-axis and y-axis. Now how this rectangular hyperbola will look. So let me just show you that. Okay. So this is my x-axis, this is my y-axis. Now let me mark these points as 1, 2, 3, 4 and 1, 2, 3, negative 1, negative 2, negative 3, negative 1, negative 2, negative 3, negative 4. So this is 0. Okay, so this is our axis. Now foremost, let me draw the line y is equal to 3 negative x. When x is equal to 0, y is equal to 3. And x is equal to 0, y is equal to 3 is this point, and if I take y is equal to 0, then I get x is equal to 3. So this is the next point. Let me draw the line. Okay, so this is going to be our line, straight line. Now the rectangular hyperbola y is equal to excuse me, 9 over x. Now how will this be? Now if I were to stretch this y-axis, the hyperbola will come like this, and over here the hyperbola will come like this. It will never touch the y-axis or the x-axis. Okay, this is the axis. This axis will go all the way. There won't be any contact. This is a beautiful question, and the graph is equally beautiful. So the hyperbola will have an asymptote along the x-axis and y-axis. Over here, x is greater than 0, y is greater than 0. Over here, x is less than 0, y is less than 0. So clearly you can see this is the straight line. Y is equal to 3 negative x. This will never intersect the hyperbola. Now the question is, they are asking us to find the solution for this. So let me write the question down. You got x positive y is equal to 3 and xy is equal to 9. Right. I will solve this and I will show you the solution for this. So this is going to be my 1, this is going to be my 2. From 1, we have y is equal to 3 negative x. And what I'm going to do is substituting in 2, we get, so what do we get? In place of y, I'm going to substitute 3 negative x is equal to 9. This is 3x, negative x squared is equal to 9. I'm going to move everything to the other side. So I will get x squared negative 3x positive 9 is equal to 0. I'm going to rewrite this as x squared negative 3x positive 9 is equal to 0. I'm going to use quadratic formula. A is equal to 1, B is equal to negative 3 and C is equal to 9. X is equal to negative b plus or minus b squared negative 4ac divided by 2 times a. This is negative of negative 3 plus or minus root of negative 3 squared negative 4 times a times c is 9. So this is 2 times of a. This is 3 plus or minus 3 squared is 9. 4 times 9 is 36. You have a negative sign. So this is 2. So this is going to give me 3 plus or minus square root of negative 27 divided by 2. I'm going to rewrite this as 3 plus or minus. Now there is a formula, I squared is equal to negative 1. So I'm going to rewrite this as 27 I squared divided by 2. Again I'm going to rewrite this as root of 27 times the root of I squared divided by 2. So this is going to be 3 root of I squared is I. Of course you will have plus or minus I present here. So plus or minus I times root of 27 divided by 2. Now 27 you can write it as 9 into 3. So you have root of 27 is going to be root of 9 into 3, which is going to be root of 9 into root of 3, which is going to be 3 times root 3. So this is 3 plus or minus I times 3 times the root 3 divided by 2. So therefore root 1 is 3 positive I times 3 times root 3 divided by 2, and root 2 is 3 negative I times 3 root 3 divided by 2. Now these are called as complex roots. Okay, now they represent elements of the form x positive iy, where x is the real part and y is the imaginary part. Now complex numbers, which we call them as the subject, or complex analysis, they have immense application in physical phenomena. Okay, that includes even medicine, right? So they have their footprint in all engineering and technology subjects. Okay, so you cannot just negate that real roots are not there, so the system is not solvable. So this is a beautiful example. Thank you everybody. Please like, share and subscribe.